Yeah,
So,
yeah,
and there's good reasons, and that way you can turn off your lights, when you're not home.
right, right.
But just the AFCIs and GFCIs have raised the price of an electrical panel, just the things like over $1,500 for single family home.
I just heard a thing on the news where lumber, lumber's been expensive lately and everybody was thinking it would come down. But they said it's not going to come down. There's too many of our sources for lumber have had bad times, like Canada. They've had some bad infestations in their forests. So that's not great news.
Yeah. The weird thing I keep reading is the price of timber isn't going up, and timber lots isn't going up.
Yeah, yeah. Well, that's part of the reason, because they've gotten blights that wipe out half the timber, so they have to jack up the price. Yeah. I wonder if that'd be interesting to see if those blights are hitting monocultural forest or mixed forest.
Hmm. Well, I actually learned something interesting about timber and lumber recently. I always we did a whole bunch of this one buy. My dad picked up everything, but a bunch of it, I thought, oh, it kind of seems like it's kiln dried or something. It was, super low moisture content, and it said all HT something. It was all heat treat, but it's not kiln dried. And I found out the heat treat is something for wood that comes from other countries to kill any bugs inside of it.
Oh, yeah. And it dries it out at the same time.
Yeah.
Oh, interesting.
But
Yeah, I found something out about trees last year. And that is, trees talk to each other. They communicate through their root systems.
huh.
Yeah, I read a whole article. It was mind blowing. I mean, these were scientists. These weren't just, mystics out there pretending all this stuff, but they're finding out all kinds of stuff about trees.
This wasn't just a review of the Avatar movie.
Yeah, close, but no, it was a pretty reputable, well, seemed like a reputable scientist, but
Isn't it spruce or one of those ones that has the largest root
yeah,
network?
yeah, it's birch.
Birch. Huh.
Birch or aspen. One of those, yeah. Yeah, they're all connected. The whole frickin' forest is connected. But trees, look out for the welfare of other trees. So I'll leave it at that. That's why we should not cut them down wantonly, but only necessarily. Okay, let's start this charade, huh? How do you sign charade? Well, it's still Greek to me.
She just signed, let's start this class.
Okay, so you guys make those kind of editorial choices, huh?
Heck yeah.
Of course. People make them when they hear anyway, so it doesn't much matter, huh? Okay, so tonight, as everybody knows, hey, welcome back, Hugo. Hugo was
Oh, yes, thank you.
out of town last week.
Thanks.
So, yeah, so we only have, let's see, 3 more classes. This one, the prep, the actual final next week, and then a final review the week after. So we're getting down to the end. So this class, hopefully we can make it short and get out of here. And then I expect the rest of the time, I expect all of you to take the rest of the time and study for the final. Just kidding. You study when you have the time. When you find the time, that's your business. Actually, it's such my tests are so easy, you don't really need to study for them, right, John? Actually, if you're young enough, which means way younger than me, if we go over this review tonight, your memory span should last you through the week. So when you get in for the final, all that stuff will still be on the tip of your neurons, right? Duke's going, God, what is this guy talking about? You know, Duke, I wish I knew, but
Hey,
Okay.
Patrick, this is Lindsay. I just want to double check. When is the test? Is the final next week or in 2 weeks?
the final's next week. And then the week after is the review of the final. So the school doesn't allow me to do that. They want everybody to have the final in 2 weeks, but I've never followed a school rule and they never fired me. Doesn't mean they won't this year, but because educationally, it's better if you review the final. You take a test, you need to know what you missed. Otherwise, you never know what you missed. Basic law of pedagogy, which for some weird reason, community colleges have forgotten. So I do it my way. So that's why you're asking, because it is different.
So tonight's the final prep.
Tonight's the final prep, next week's the final, and then we're going to go over what we missed. And with
Okay.
those three approaches, you should know most of what you need to know from this class, or a lot of it. Okay, so you know, when I have these finals, I don't think you can see it. I have two columns, and then you're supposed to do a line between them. You've seen those on tests, right? But I can't do it with the Zoom, with the Canvas setup. So, because you don't, you know, there's no way you can write or do anything creative on the screen. So I do this a lot. So I did it a test, I guess the midterm, I think I did it, and I screwed up on it. So I'm not even going to hassle myself. I'm just going to ask individual questions, you know, and give you a choice, multiple choice. That's the same thing. So the first 4 or 5 questions on the exam are about construction materials and estimation, and particularly the kind of unit we use. So if you remember, we talked about ordering wood and concrete and roof shingles by different units. All those materials have different units. So you need to know, in order to order them, what the unit is. And you also need, therefore, to know how to figure how much you need of those units. That's part of the, you know, you look at the plans, you figure out the size of something, you convert it to the right units, and then you ask the lumberyard to send that out. So, for instance, baseboard we talked about, and baseboard runs the whole house. Usually the whole house has baseboard, and there's little walls and big walls and medium-sized walls. So they don't just buy a 7-foot piece and a 12-foot piece. They'll buy either a bunch of 16-foot pieces, or they'll buy a mixture of 8, 10, 12, 16, whatever the lumberyard has and what in the past makes sense. And then they, when it's on the job, they'll economically use it, cut it up. But they order it by the foot because it's just too hard to order it by the piece, to order 8-foot pieces and 10-foot pieces. You know, you'd spend hours on the blueprints trying to figure out, you know, the exact numbers of exact lengths of baseboard. So usually they take those little, they have those little wheels. Have anybody ever seen those? And they run them over the blueprint. It's like, you know, you have them for when you walk, right? People have them to pace off what they walk. And you can do that, and you just do all the walls in that, and then you know the total length of walls, and that's the total length of baseboard, and you just turn that in. I need 1,000 feet of baseboard, and then the lumberyard ships whatever they happen to, you know, they usually stock it in the lengths that builders like. So baseboard, you would put linear feet. You would order it in linear feet. That's not always. Some people will order it specifically, but I'm trying to get different units here so you get the idea. Sheathing, 4x8 pieces of plywood. Does anybody remember? I know some of you guys work and use it, so you know how it's delivered, but so what's the unit for that? So you may not know the name, but you know it's ordered by individual sheets, right? I need 50 sheets of sheathing. And so I use the word piece. You know, you order it by the piece. You order one piece of sheathing or 50 pieces of sheathing. So baseboard, you'd put linear feet. Sheathing, you'd put piece. The unit is a piece, P-I-E-C-E. I know when these things are over the internet, the sound's not as good, so it's probably a good deal to write them. Can you see that? Yeah. So unit piece. Linear feet is abbreviated LF. Okay, there's another unit called a square.
Sorry to
What's the-
interrupt. Will you
Yes.
add me to multi-pin? This is Hugo.
Oh, sorry. It's been so long, Hugo, I forgot. Okay, great. Whoops. I almost said it. So squares, what do we order in squares?
Roofing felt and shingles.
roofing material. So yeah, roofing shingles, we order in squares. And a square is 100 square feet. So if you have a 10 by 10 roof, a little playhouse in the backyard, you have 10 by 10 shed roof, that's 100 square feet. It's going to be one square. You're going to order one square of shingles for that. Well, there might be waste, so you might have to order more, but anyway, you get the picture. I think, John, isn't that the only use of square and building units?
I believe it's the only modern use.
Yeah. And then concrete. So concrete's a liquid, right? Or would you call it liquid? A plasma. In other words, it takes its own shape. So that we're going to order that by the cubic yard. You see that low?
Yeah.
Getting close though, huh? So concrete, sand, if for some reason you need a lot of sand, or dirt, if you're filling something, any kind of fill, those would be cubic yards also. How about studs? Anybody? One of those, maybe? One of those, which one?
Piece.
Yeah, it's a piece. You order 200 studs at 8 feet. Plate can go different ways. I always order it, in my work, I've always ordered it by piece because I know, the walls, but it's a lot like baseboard. You can order it by linear feet also. But with baseboard, you can splice together pieces. You don't have to have a piece of baseboard that covers the whole wall. If it was a 20-foot wall, you might put a 12-foot piece and a 10-foot piece in there. But with plate, you can't do that. You can actually piece it together, but it's not as good. You want every wall, you should have continuous plate. It's easier to put together and to stand up and to deal with. So, and rafters and joists are piece also. They're fixed lengths. you have a 12-foot rafter, 2x8 rafter, you're just gonna get 50 12-footers. So, okay, I think you'll do fine with that. Okay, so the square, I'm gonna give you a number for the square foot of a roof. And I'm gonna ask you how many squares that is. How many squares of shingles to cover it. So it's just the same thing we just did. The square is 100 square feet. So you take the area of your roof and you divide it by 100. You take the square foot area of your roof and you divide it by 100 square feet. That tells you how many squares.
And then let's say it was like 157 square feet. Would you order 2 squares of shingles? Because you have to round. Do you have to round up on that, or is it?
No,
Like
you can order
three-
fractions of squares because they actually deliver them in bundles, which are less than a square.
Okay.
Yeah, but you do have to add a waste factor onto that. So if you had exactly 157 feet as your area, then you still add a 10% or whatever shingle waste is. Every product has a specific kind of waste, and you can get books, or Lumberyard would probably tell you, what factor, what percentage to add on to each particular material. It's harder when we're starting or when we're just doing stuff for ourselves because we don't have the experience, but companies who do a lot of building, they know exactly, how all this works. So then I'm going to ask you to list all the materials that go into a wall, an exterior wall. So you got a house, it's got exterior walls. On the inside, there's sheetrock. Then tell me what's inside the wall. There's wood, there's other things. And then what the outside covering is. You can pick a specific kind of wall, or you can just use general terms like instead of stucco, you could just say exterior covering. And if you go, this is open book, right? An open note. So you've all got the blueprints. This is blueprint reading, right? This class? Yeah. So you've all got the blueprints in your file section in your Canvas, which you can use during your test. And so just, find a blueprint and in the details section, or occasionally in the what do you call the slice? The
Section,
what?
section,
Section, thank you. In either the section, sometimes the section will have a whole wall section because they want to show you what materials go from foundation to roof. So that's a great drawing for getting all the material. And if they don't have a section drawing, they probably have a detailed drawing with all the material in the wall. Okay, so I don't know if this is going to be on the test. I was taking a bath this afternoon and I kept thinking about it. I don't know why, and I kept trying to solve it. You get that way when you're nutty, So board feet. This is my final approach. Okay. So the book and Rodney Utt, Dr. Rodney Utt, used this formula. Board feet. Can you see that?
Yeah.
Board feet equals, now I've got foot and inch marks. Those are really critical. So if you copy this down, make sure you've got the double line or the single line. So the formula the book uses, and this is a simpler formula, which is why Rodney uses it. Now I'm not saying Rodney's simple, okay? He likes simple things. So width in inches times thickness in inches. So if say it's a 2x4, you want to find out the board feet of a bunch of 2x4s. So the width would be 4, and you use the nominal size, okay? A 2x4, you'd use 2 for the 2 and 4 for the 4. You wouldn't use 1.5 and 3.5, okay? So always board feet go with the nominal sizes of lumber. So 2 by thick times 3 wide times the length in feet. Now these were in inches, 4 inches, 2 inches, and say it's a 10-foot long piece. You'd use 10 feet. Now in math, normally you're only supposed to multiply with equivalent units. So in a normal math problem, you couldn't multiply feet times inches. It doesn't work. But I'll show you in a minute how they get away with that. There's a lot of formulas in building where they've done the formula and they've gotten that whole formula, which everything's right, and then they've simplified it. And because they simplified it, you just have to go with what they say. You can't think about it. Just perform the algorithm and be with it. So width times thickness times length in feet over 12, no units, just a 12. So that's the formula people use. Also, they might have times a number. Like if you want to find the amount of board feet in a 10-foot 2 by 6, you don't need the number because it's 1. But if you're trying to find the board feet of a whole pile of wood or the amount of wood you need for a wall when you're going to the lumberyard, then you're going to put the number of those pieces you need. Like say it's 2 by 4, 8 feet, 50 of them. So you make sure you multiply the 50. Now, or there's another formula, and this actually could be a formula to use to make sure this one's right. So if you can't remember this and you're not sure if you got the numbers right, use this one because this is just the straight math. So in this one, we have width times thickness times length, all in inches. So when you multiply that, you're finding the cubic, the volume, the cubic inches of whatever you're trying to convert to board feet. So when you have length in inches, it's going to be a lot bigger number than 8 feet. It's going to be 96 inches. And it could be even larger if you got a longer piece, right? So you're dealing with longer numbers. That's why this formula is great, because when you leave the feet as feet, usually 20 is the biggest length we use in building in a normal house. So this has smaller numbers, but this is a backup formula. It means the same thing. The volume here is width times thickness times length, 3 dimensions. And then you're going to do just like you did on the roof. You find the total volume of the roof, and then you take the volume of a piece of sheathing, 32 square feet, divide it in. You're doing the same thing here. 144 is what the cubic inch volume of a board foot is. So you're saying the total that you have divided by what a board foot is, and that'll get you how many board feet. The only difference is you're using larger numbers, and unless you have a calculator, it's pretty hard to do. This you can actually do without a calculator for a lot of them, if you're pretty good in math. This one will probably, since you're dealing with inches in length, you have a 16-foot board. How many inches is that? I don't know. So this is what they did. If this were in feet, I mean, to make this to make this in inches, we multiplied the length in feet by 12, right? Say this was an 8-foot piece, 8 foot times 12, so that would be 96. It's a bigger number than this number because you're dealing in inches. So because we multiplied by 12 to get this, so we take the 12 out of there and we have to take a 12 out of here. So if we divide top and bottom by 12, we end up with this formula. And you can do that and it makes it simpler. It crosses the units. It's kind of mathematical magic, but it works. And you're dealing with different numbers. So that's all we're going to say. Does everybody understand that? So you can just write down this. If you
Sorry,
use this
Patrick,
and
this is your interpreter, Katie speaking. I'm not seeing clearly enough on the board, so I understand that you're canceling out your 12 at the top. How are you removing and canceling 12 at the bottom on your second formula?
because if you're taking 12, I multiplied the length times 12 to get the length in inches, right? So we had this formula, and if you multiply this top by 12, you get that length in inches. If you have 8 feet and an 8-foot length, if you multiply that by 12, you get 96 inches. So since I
Got that
multiplied,
part.
yeah, so if I want to get rid of that 12 and just go with feet like up here, then I have to divide this by 12 also. You have to divide top and bottom by 12. So that's how we get that. And then that's how we get that. It's really the same formula, but this one you can't really conceptualize it because they've done this behind the scenes manipulation of the terms. So you just have to memorize this one, and it's a great formula to memorize because it's so simple. And you're dealing with feet. I mean, it's got, you couldn't make it easier. That's why it's in the book, and that's why Senor uses it. And this one's just the standard way. You take a total volume and divide it by a volume of the object you're doing, and it gives you the number of the amount of object. So I just wanted to show you how this one this was the original formula, and they just divided them by 12 to make it simpler. So if all this is too confusing, just go with this formula here. Just memorize that one. Some people like to know where formulas come from, like Alec and John. Don't cross me, just say yeah.
Well, one thing, when you're ordering lumber by the board foot, a
Yeah,
lot of times it's expensive wood because you're ordering a hardwood or something clear. And a lot of time, like for instance, I'm building a gate that's 39.5 wide by 56 tall. I need it by the inch because
Yeah.
it's $1,500 of wood and I need to be exact.
right. So, yeah, so actually this would be better, this other formula. Yeah.
Yeah.
Well, because we deal with that type of formula for sheathing and sheetrock and shingles, we already know that template of a total of the total area of what we want to find, and then the area of the object that's going into it. So we already have that template. That's why I brought that up. You can look at it as part of that template or just as a streamlined formula, either way. So I like to find out why people do things. There's a lot of formulas in building, and they do this behind the scenes, and you think, well, how can I multiply feet? Why will that work? And the only way you can figure it out is to start with this formula and see what they did. Okay. So we talked about laying out a wall, right? Building. We did a little bit about going from blueprints to actually constructing the frame. And say you've got an exterior wall you're building on the ground, you're going to stand it up in place, and that wall has a door and a window in it. So And it has also has an interior wall that intersects it about 2/3 down. So it's got those three things: window, door, and intersecting wall. So there's three. So what are the three layouts? There's three layouts that converge on that wall when you're laying it out to frame it.
Are you saying in what order do we lay
Yeah,
things?
that's what I'm getting to. First, let's get yeah, exactly. First, let's get how many layouts there are. I mean, it's really just one, but you can look at it as three different stages. So obviously we have the stud layout, say it's 16 on center from one side of the wall to the other. That's one layout. Then we have, what's another one? What did I say was in the wall?
Like rough openings for doors and windows?
Yeah, so doors and windows aren't going to fall on the 16-inch layout. Although with advanced framing, architects are advised to at least have one end start on a 16-inch frame. They're not going to be 16, 32, 48 wide necessarily. They're going to be uneven numbers. So you're not going to get both sides to fall on the framing, but you could always get one side. And in that sense, that would be hard to do a center line. Remember we said doors and windows were laid out by center line. You go from one end of the wall to the center of the window or the center of the door. But if you're trying to get it to go on stud, you should say, the architect should say, put the center line here and the nearest stud to the left of the window, make it even with that. Because they're not going to be able to put an exact distance to one end of the window. But they could easily annotate it and say, we're going to get this close within an inch of the window. When you frame it, just push it right up to that stud. So your king stud will be one of the layout studs. Instead of having it start in the middle of the stud bay, eight inches in from the last stud, and then all of a sudden have a window start there. You break up, you don't need that stud. You could just start the window even with one of the studs in the layout, and you've eliminated one piece of wood right there. Okay, so we've got windows and doors is a second layout that overlaps. We put that on top, the layers. And what's the final one? It's the third object I mentioned. That's why I know that's what you're all trying to remember. So interior wall partition, right?
The channel backing.
Yeah, well, so you're gonna have to mark where that wall comes in on your plate of that first of the wall you're building, right? And even though, say your advanced framing, so you don't have a ladder where that comes in, or you don't have a wider piece of framing that interior partition nails against. If you're trying to eliminate wood, you'll eliminate those. You still got to know where it's going to fall in the bay in one of the stud bays, because on the plates, because that's where the wall is going to go. I bet you could all use a drawing, huh? This is probably easier, but when you put it in words, like half the things I talk about, it's kind of more confusing than it really is. Can you, John, can you shorten the time a phone rings? Can you just have one, what do you call it? In music, what do you call, one bar?
One bar.
Yeah, like,
Probably.
you know, we used to play a game in high school where you get two notes and you had to guess what song it is. You ever play that game? You know, da na na na, or you know, three notes.
Yeah.
But it, you know, we were all hearing the same music, so we could tell. We knew it wasn't Beethoven or Mozart, but it was whether it was the Beatles or the Stones or something. Oh, my phone just rang, and it seemed, you know, I hate it when it goes on forever. I can't shut phones off because then I forget they're off, and then I don't hear from anybody for a week. See, when you get old and senile, you can't just do the reasonable things. So how do you say senile in sign language?
I do that now, and I'm not old.
I just
you
signed
guys are-
old.
Yeah, you get old and, you know, crazy in the cabeza, huh? Okay, so the red is the stud layout. So that's 16 on center all the way across. But you got a wall that's coming in. You got to mark it somehow. And then you've got to mark your windows and your doors. So the three layouts in this wall. And it's all one layout, but they're layers. So what I do, and this won't be on the test, but it's related to this, is I always lay out the windows and the doors first. Because the studs that fall, if a window is 3 feet, it's going to take up more than a 16-inch stud bay. So you've got to mark where those studs go, because you've got to have cripple studs in the window above and below and in the door above that are going to be on layout. That's what these dotted lines are. So you won't know where those are. If you mark the stud layout first, you're going to mark all dark lines, and you won't know which one of those are cripple studs until you do the window, and then you've got to erase the whole line and put C instead of X. So do the window first. You'll know where the window stands, and then when you do your 16-inch standard layout, when it gets in the area of a window, when you mark it, you'll mark it and you'll put a C instead of an X. So, and then you can do the wall probably in either of those sequences. So it just saves you time, and you don't have to erase stuff and remark. Okay. Then remember we talked about foundations. We looked at foundation prints, and we looked at details, maybe cross section of the foundations. That's fairly common. So when you're going to form a foundation wall, and it could be, I don't specify whether it's a slab with thickened edge or a upside down T, raised foundation. You can do either one. I want you to list what kind of materials go into that foundation. So there'll be wood for the form boards. You might spell out the kind of wood if you know. It'll have concrete. There's other things that'll have. The wood doesn't just float in the air, right? Unless you've invented some kind of cosmic, hovering device. And if you had discovered that, you wouldn't be taking this class now. You'd be on your vacation in the Bahamas. Okay. So do you remember what a gray water recovery system is?
No.
So, we usually call them gray water systems, but they're really recovery systems, right? We're using the gray water for something else. We're reusing it. A gray water system could just be the drain. All your gray water goes out to the sewer and out to the ocean. That's still a gray water system, but that's part of a drainage system. But when you say gray water, you mean in some way you're recovering that water for some other use, right? So gray water systems aren't standard systems. You just have your supply system in a house, supply water, and then you have your drainage system. Those are always the two systems. Gray water system where you're piping the gray water somewhere out to your yard, recycling it back into your toilet or whatever. That's an added system. Not everybody has that. So just remember that. DMV. Remember what that stands for? Drainage, water, and what? Ventilation? No. What's that stand for? Come on, you guys.
DMV?
Yeah.
I think it's drain, waste, vent, something.
Yeah, I suppose so.
Vent.
Yeah. I was trying to include the supply system in that, but that's its own unit. So the wastewater is called DMV for drain, waste, and vent because it takes a vent. You have to include vents with it.
Wait, what's the M?
They said waste.
I think it's a
No,
W.
DWV.
Okay.
Oh, I was thinking the same thing.
Yeah. No, you know what DMV is. We don't want to talk. That's the D word. We don't want to talk about it. Okay, and then I'm going to ask why vents are needed. Why vent stacks are needed in plumbing drain systems. And then I'm going to ask why lines get bigger. The diameter of the lines get bigger as they leave the house. Or rather, as they get closer to the sewer, the main line that goes out of your house. We may not have talked about that, but it's just an obvious logical thing, right? I'm going to ask you what HVAC stands for. HVAC. I'm going to ask you for two types of space heating systems.
Two types of what?
Space heating. So to heat your house, the airspace in your house, what do you call the forced air is with the furnace, and then the fan blows the air around. That's one of them. And we've talked about a couple others. It's in your just look in your plumbing handout. Or, I mean your HVAC handout. Then in electricity, know what electric circuits do? So, remember we talked about in the electrical prints or lack of electrical prints that they don't really have maps of the whole circuitry in the house, where in the walls they go to connect. The electricians kind of make their own maps as they get there. But what we do know is what's on the floor plan, and that is where every switch is located and where every outlet's located and where every overhead light's located. And then they put dotted lines connecting them. So they have a front door switch and they'll put a dotted line to the overhead light that's in the living room. But obviously the circuit doesn't go, the circuit doesn't go over, that curved line. That's just direction line to tell you what's connected. The circuits all go in the walls and ceiling. So what was the question? So where do circuits start? I'll give you the particulars to answer the question. Where do the circuits in a house start?
The source from like the power source, like the main.
Yeah, so well, the source of the power is the utility company, right? But in your house, what's the source of power? When it arrives into your house, where does it go first?
Box.
Yeah, the panel, distribution
service?
panel. I mean, it's got 100 names, but it's called a distribution panel because it distributes the circuits. And then if you think about going from there to all the outlets and the switches we talked about. Okay, new distribution panels contain fuses or circuit breakers?
Breakers.
Breakers, yeah. I think there's still fuses for certain types of switches. You know, big shutoffs for various things. But in your normal distribution panel, it's now breakers. GFCI, ground fault circuit interrupter. That's the outlet that has its own circuit breaker in it. So when you have a short in an electrical circuit, it will shut off the breaker. If it's overloaded or if there's a short, it'll signal the breaker. And it goes pretty fast. You know, electricity is almost the speed of light. Goes pretty fast, but it's not quite fast enough to keep you from getting electrocuted. So in order to keep more people alive, for all the outlets that are near water, drain boards in the kitchen, near sinks in the bathroom, near bathtubs, they have GFCI. They have their own circuit breaker in the outlet. So if there's any water splashed on them, they shut off immediately, faster than if it had to go all the way to the distribution panel. So if you were taking a bath and you had an outlet, they're supposed to be 3 feet from the bathtub. I put one in a foot away because I'm stupid. But yeah, because you know, you don't want to get water on that thing. And they also want to discourage people drying their hair in the bathtub. But if you have a hair dryer plugged into that GFI, and then you're really mad at your husband or your wife one day and you throw the hair dryer into the tub, it'll probably shut off before they get electrocuted. Isn't that good to know?
Thanks. Yeah, you spared me. I was gonna try that one.
Yeah, don't do this. Don't try this stuff at home.
It doesn't even work anyway, so I won't even try.
No, actually, I don't know that would work, but I think it would. I think that's the kind of thing they're trying to
Hope
prevent.
so. We hope so.
Yeah, but don't try it.
Okay.
So schedules, blueprints called schedules are not sequences of activities, right? Which is what the normal meaning of schedule is. So for some reason, construction people use it differently, but you know what it is, right? What the schedules are. And for example, a window schedule, I'm going to ask you what it contains. So go to your window schedules in your plans. Half of our plans had them. And then just look at the kind of things that it says about windows. And I'll give you one hint. Nowadays, they often have rough openings, but our plans are also old. I don't think many of them had rough openings, but that's really important because sometimes you don't get the windows delivered to your job until after you framed. And so if they don't fit the rough opening, you kind of have to reframe, which nobody wants to do. So you need to know when you start framing what those rough openings are. And so you could write to the people that, make the windows, or when you ordered them, they could send you that if you ordered them before. But it's easier to make the architect do it and have the architect, since the architect's going to prescribe the manufacturer of the window anyway, then he or she will probably have a catalog in their office anyway that has all the rough openings for all the windows in the catalog. So that's one thing. There's other things it contains too. So just put, some of the things that's on that schedule. Okay, and we talked about specifications being obviously they have information for how to build the house, but they also that information is legal, right? So if there's any discrepancy about how something was built, something failed, and someone's looking for something to blame, like the lawyers that the owners hired, if the house isn't built according to those specs, the builder, the contractor, is liable for the mistake. So it's a legal document also. And then do building departments need to know the specifications in your building?
Building department need to know?
Yeah.
Nah.
We don't need to tell them.
Yeah, they have to know because, I was going to say they can make money on it, but they don't. They actually tell you before you build. So when you turn in plans to the building department, they have a, what do they call them?
Plan checker.
Plan checker, thank you. Sometimes they double as inspectors, but big places, they're just plan checkers. And they will go through your plans and make sure your specifications are actually correct. Because you can have specifications that aren't, that aren't engineered right. So they need them too. Rough opening, I'm going to ask you what that is. And I've got one, I'll probably tell you this one because I'm too tired to explain it. Electrical circuit pathways. Well, you guys answer this, okay? Electrical circuit pathways are shown on floor plans, true or false?
False.
Anybody else? There's always the guy who says, well, he said false and the teacher wants another answer, so it must be true. But you didn't fall for it. You guys are too sharp. Yeah, it's false. It's false because what's the word that gives it away? Electric circuit pathways? Pathways, right? That means where the circuit actually goes. And we just got through saying those aren't on the floor plan. The floor plan has what look like pathways. They're little arcs, dotted arcs, but they're merely connecting the switches to the lights. And the electrician has to know that much because, he wants to know what switch works, what light, what outlet, that kind of thing. And the client also wants to double check and make sure the architect puts everything in the right place. The client may say, when we come in and we're holding packages and that's a bad place for the switch, we want it moved somewhere. So it's real important where switches are in terms of doorways and passageways and outlets. You want to make sure they're where the tables you're planning on having are, if you're going to put a switched lamp, for instance. Okay. And the architect, who locates the overhead lights and the switches and the outlets, the architect or the electrician?
I think the architect does lights and the electrician does plugs.
Okay.
Or the exact location.
Yeah, I'll say architect does it only because they may want them in a certain place. The client may have said, look, we got to have them in this corner because we're going to have our big TV here, that kind of thing. You know, that floor plan you saw had outlets on it, and the architects who drew that. So I think you're right, though, that the architects will say, just make sure we have an outlet here and then put them where they legally have to go after that. So in that case, they'd both be doing it. But the answer I want is for the designer, for the architect, okay? That's a good point, though. Plumbing pipe pathways, as opposed to electrical circuit pathways, are shown on floor plans. True or false? You know, where, you know, which walls have the pipes in them, vents, drains.
False, Patrick.
Both what?
I said false.
You said what? I'm sorry.
False?
Oh, false.
I mean,
yes.
there's
That's right. It was a true and false question. I forgot. Yeah, it's just like the electrical. You know, the architect doesn't know that much about plumbing or electrical, so he's not going to design, he or she's not going to design that. So they'll specify where owners want certain things. Like I want a sink here and I want the toilet here. That's all part of the initial design. But as far as how to get the water and the waste away from there, that's all the plumbers. They don't want to know about it. Just make sure all those things work. So the plumber will go in and design that also. Except for, I think if you look at that Laguna Blanca plan, where it's really detailed in terms of, like say you were doing an art studio like that, and maybe it was a ceramic studio and they had to have, you know, sinks for getting rid of the water when you're throwing pots, and those could be, a lot of that stuff could be specified. Also public access toilets, and that also have, you know, the handicap layouts, those will probably show more. But residential houses, they don't touch that stuff.
Did those plans have a electrical and mechanical engineer?
Yeah. Yeah. Name 4 plumbing fixtures.
I missed that. Say it again.
The question is actually name 4 plumbing fixtures. So you have to go back to that sheet and look at look up what a fixture is. Name 3 types of inspections and when they occur in a house build. So go ahead and name some here. We can talk about this one.
Rough plumbing.
Rough plumbing. That's one.
foundation.
Foundation, they have to inspect the before the pour. You know, everything that the concrete's going to go into, they have to make sure everything's right. So that's another one. That obviously would come before the plumbing. Well, the plumbing rough end, well, those could be the same time. You know, because they have to rough in passageways through the concrete. Yeah, you would have to pick ones that overlap, wouldn't you?
Is there one for the grade? Like when, I forgot what it was called, but when you grade out like a lot of land?
Yeah, you know, I don't know, but John, do you know? It sounds like there probably would be.
Yeah, I've never worked on anything that big before though, but there is something.
Yeah. Yeah. What other ones did we talk about? What other inspections?
Frame? Did you inspect the frame? They gotta inspect that, right?
Yeah, framing. And the framing could be done when the electrical and plumbing are done. And then after that, what goes on after the plumbing and electrical junk is in the walls? Can you seal the house up then? Seal the sheetrock?
Insulation inspection.
Yeah, then you need insulation, and that needs to be inspected now too.
And
Is
then
there
you
sheet-
have to-
Is
Yeah,
there
then
an
she,
inspection
what's
for,
that?
Is there an inspection for fire suppression systems like sprinklers and things
Yeah.
like that?
Yeah, that would be part of the electrical, I think,
Plumbing.
or plumbing, yeah, I mean, well, it could be both. And then there's, sheetrock has to be inspected because they have to check the nailing or screwing, whatever you do. It has to be, you know, there's a nailing or screwing schedule for sheetrock, just like there is for sheathing. And so you can't mud over that. You have to put it on and then you call an inspector. He makes sure the nailing's right and then you can mud. And same thing with stucco. They have to check the wire, the stucco underlayment before the stucco goes on. So there's a bunch of inspections. And then there's finals for all those, final electrical, final plumbing. So you don't have to name all of them. What did I say? Just a few? Oh, 3. Oh man, you got that made. Oh, where do most electrical solar panels store electricity for nighttime use? Most electrical systems. Note the word most. There's a couple of ways, right? What are the ways that, what is the storage for solar electric?
Like a battery?
Batteries are one. What's the other one?
You give it back to the utility company, right?
Yeah, the grid. You can store it in the grid. You don't really store it. You send it back to the grid. Your meter works in reverse and it records how much credit you get for the electricity. And then they use that electricity. It's not really yours. You can't own electrons, but I mean, it's yours in the sense that you paid for it, so you get that money back. But right now, I think there are more grid stored electrical systems than battery. That's going to change. Eventually, it'll be all battery. We won't have a grid because we won't have fossil fuel power to keep that grid 24/7. That's the reason we have the grid, is because when wind doesn't blow and sun doesn't shine, we still have a backup fossil fuel, base of electricity. So in order to completely get rid of fossil fuel, we'll have to have our storage working. And we're working on that. That's not resolved yet completely. We talked about the switches and the outlets and overhead lights on which plan, which blueprint?
Floor plan?
Yeah, floor plan. What about a lighting schedule? I think we have a lighting schedule on one of those plans. I can't remember which one. What kind of information would be on there?
What kind of fixtures?
Yeah, you've got can lights, different size can lights, LED lights, all that kind of stuff. Outside lights, taking certain kind of light. And we said commercial buildings will often have their mechanical plans, which is electrical, plumbing, and HVAC will be more complicated. When you're conditioning air for a commercial building, it's a lot different than a house. And same with electrical, lighting, all those systems that rely on on electricity, fire systems. So they're going to have plans for each of those. And we saw a little bit of that in the Laguna Blanca, because it was a studio, a public building studio, which is on par with commercial plans. The main types of plumbing, does anybody know what those are? I think we talked about it, but does anybody remember? Main types of supply, I'm sorry, supply lines, supply pipes. We used to have plastic and copper, and then they outlawed all the plastic except one particular type.
PEX?
Yeah, and then they introduced PEX. So right now it's mostly PEX and, you know, in Santa Barbara County, it's mostly PEX and copper, but probably in other parts of the world, they're using plastic because it's cheaper.
Somebody told me that all new houses are using PEX. That's like the standard now.
What was that? Say it again.
I forgot a while back. Somebody told me that all the new houses that they saw being built, that the standard they were using was PEX.
Yeah, well, it's cheaper and in some ways it's simpler. So I know it's been going toward PEX, but I don't know, have the data.
Yeah.
You know.
PEX.
The builder just chose to use it or something.
What's that?
I said it could just be the user. I mean, the builder chose to use that as.
Well, no, the architect would have to design it. And yeah, now, you know, with green building, sustainable building, one of the values they have is getting everybody together before they design the house. So the plumber and the general contractor would say, okay, what kind of piping are we going to have? And because PEX is actually more sustainable than copper. And so the homeowner may say, no, I want everything as sustainable as possible. So I don't want to use copper because we're running out of copper. And so that ahead of time they would know. So when they did the plans, the architect would say, specify PEX. If they specified PEX and the owner had an opinion and saw it, they could change it. They could say, oh, I noticed you have copper down, we want PEX. But yeah, so, you know, if they get together like green builders are trying to do, all the subs, the contractor and the owner, and iron out a lot of these issues ahead of time, then the plans get drawn once instead of a million change orders. So I would say copper and PEX are for this area. So plumbing fixtures, like say a toilet, what plan would that be shown on? The main place. There's a couple places.
A mechanical or plumbing plan?
No, there wouldn't be a plumbing plan for a residence. So
On the floor plan?
on a floor plan. So the floor plan's job is to put all the fixtures and anything that's in the house, walls, toilets, steps, everything like that is on a floor plan. Now, on our Laguna Blanca plan, again, where you need to show elevations of sinks and toilets for handicap purposes, ADA purposes, then you would have a section drawing, you know, through the building right down the middle of the bathrooms, and it would show where all those things are located because the inspector will want that. So sections could have toilets, but normally in a middle-class residence, you wouldn't have a section down a bathroom unless there was something really unusual, but always on a floor plan, you have to list all that stuff. Okay, drain pipe. There's two kinds, PVC and ABS, the black stuff. I don't know, is there any new stuff besides those now? Okay. Now that's,
I'm sorry, I was behind you.
Yeah.
This is Katie again. Just
Yes.
rewind that one. What's the topic? You said it sounded like HVAC?
no, that was plumbing.
We just
And it
finished
was
plumbing?
Yeah, drain pipes,
Oh,
drains.
drain pipes, thank
Yeah.
you.
And those would be PVC, initials PVC for polyvinyl chloride. That's a nasty plastic, but we're not drinking it, so we still allow it. Not drinking from it. And then ABS is that black pipe you see, the black drain you see in the Home Depot or you see in homes. You know, there's tile. They use tile for drain pipe too, out in under the roads, and your lateral sometimes is tile, but that's not in the house. We're talking about in the house.
What does ABS stand for, Patrick?
Oh, it's probably in your modern carpentry. The spell, I think I spell it out. I have no idea. I used to know, but I keep forgetting it. Polyvinyl chloride, you remember because there's such a controversy about it. It had, what are the stuff it has? The bad stuff? There's a name for the particular chemical, dioxins. Is that it? Yeah, so we're not allowed to use that as supply line anymore because the plastic sloughs off this nasty toxic. So solar hot air. Yeah, anybody remember that? So usually we think of solar as hot water or electricity, right? But they do have panels that create, that warm up air, and the air is fanned through the room below. Just remember that. And then a heating system consisting of furnace and ductwork is called, that's a question. And then a heat pump can often replace a forced air heating system. Okay, so here's an example of, if you're having trouble with a question, try to remember if that area was discussed earlier in the test. Sometimes the words are in another section, another question. So that's a test taking skill.
Can you repeat the last question you just said?
I can. A heat pump, that's a type of heating. It's a heater that's on a wall and it just draws in air, and it acts like a refrigerator or a air conditioner. It extracts heat from even just slightly warmer temperature material. I don't know what they call that, but that's the process that's really catapulted HVAC and things. And so they're replacing, are they replacing forced air heating, which is the one with the ductwork and the furnace? And the answer is true. They are replacing. The question is, a heat pump can often replace. So it doesn't say they're replacing, because people are still using furnace and ducts, but it can often replace. That's an ambiguous phrase, isn't it? I use those so I don't get in trouble. But the answer is true, so just write that down. Conduits, what are those?
Pass the electrical through?
Yeah, if the electrical runs inside the wall, it can just have a sheathing on it, like Romex, the yellow and white, rubber covered wires. But if it runs outside the wall and it's exposed, like you're adding it onto a building, or it's a concrete building and you can't hide stuff in the wall, or it's outside, you have to put it in this metal, either flex or rigid conduit to protect it. And we talked about geothermal. What is that? Geothermal heat, residential geothermal.
Only like something to get out, cooling out of the ground, like out of a hole in the ground or a well or something like that.
Yeah. So they can put pipe down into the ground, either straight down if you can drill down, you don't have rock, or if you got a lot of land, they can do it laterally, like 4 or 6 feet under. And the earth under 4 feet is about 55 degrees year round. And that's really warm. It seems like it's chilly, but compared to a 32 degree outside temperature, that's warm. And they can extract that warmth with a geothermal heat pump. So where people have the land to do that, that's a really good, it's a real simple way. You're just extracting the heat from the earth that's already there. And you use, pumps and fans, and you don't hear too much about it because in an urban or suburban area, we don't usually have the yard space to do that. But so it's sustainable because it's right? It's natural and it's not using a lot of energy, right? Okay. And remember the handout? I know Hugo wasn't here, but the handout we did last week on commercial buildings. And it was all about steel and concrete. Remember that? It was about
Yeah.
steel frameworks and rebar fortified concrete floors. So the question is, do commercial buildings use that kind of construction? And the answer is true. Rebar, this is a practical question. Rebar has sizes. You go to the lumberyard and they say, well, what size, what diameter rebar do you want? And it's got number sizes, like 2, 3, 4, 5, 6, whole number sizes. And those numbers stand for the number of eighths of an inch. So a number 3 rebar would be 3/8 of an inch. A number 5 rebar would be 5/8 of an inch. That's probably a true and false question. Oh yeah, in those buildings, they use a lot of reinforcement for the concrete, just like we do in our residences. We have a stem wall or footing, has to have continuous concrete. So in a building, you're just pouring concrete into a couple of feet, maybe 6 inches wide, not a huge area, and it's not going to take a lot of flex. Houses don't flex that much. So we wrap wire around it. I can't read my question. Hold on. I thought I was going to ask another question, but the question I'm asking is if rebar is only 20 foot long, right? Maybe commercial buildings, they make humongous ones, but residentially, Home Depot and Hayward, you're just going to get 20 foot long lengths. And so if you have a 30-foot wall, you've got to join a couple of pieces, right? So there's that, they have to lap. And you don't want them to pull apart in an earthquake. If they're not connected very well, it doesn't work. So you have the wire, and I think in commercial buildings, they probably weld them together. But the amount they overlap is important. And that's just a true or false. That's true. There's specified amounts for the diameter of the rebar, where it's used, that kind of thing on the overlap. Like if you're doing a house, the building department will say that rebar has to be lapped, a foot or 6 inches or whatever. And last question. Oh no, sorry, we're almost there. Steel beams and posts are always welded together, true or false?
True.
True? Who said that?
I said true.
No, remember in the handout, did we see it? We saw a couple of films too, didn't we?
Yeah.
Remember those guys putting bolts through holes?
Ah.
Yeah, so believe it or not, even in huge skyscrapers, they'll put them together with nuts and bolts, parts of it. So soldering, welding is also used. So they're not always welded together, so that's false. Okay, I'm going to have you add some lengths. I'm going to put 3 lengths, and you're going to add them. So most of you did well on the examples we've had. I think we had a couple on the other test. But for those who didn't, this is something that I just really emphasize in my math classes is, we're always in a hurry to do things, especially on a job. Your boss wants you to do everything as fast as you can. So we're always taking shortcuts. And remember when you grew up and you took math and you did a lot of stuff in your head. One, because it was cool, so you could show off that you could keep all that information in your head and get the right answer. But it's not that cool when you make mistakes in building. So really, unless you're just a super genius with math, and I know I'm not, I write down stuff a lot because I don't want to make mistakes. I've made mistakes, and I said, well, if I wrote it down, I probably wouldn't make those stupid mistakes. So when you see, a lot of this problem is an addition problem, and it's feet and inches. So what's going to happen is you've got three lengths. They're going to go over 12 inches. So you're going to have to carry. So whatever sign system you use that shows that you carry, and you cross out the original number and put a lesser number if you carried, go to the lengths to put all that stuff down. Go slow and do it the long way and get the right answer. Because sometimes, like on the other test, I gave partial credit if I could tell you were doing the right process, but you just made a stupid mistake. But this time I don't want to see it. I want you guys to really spend a second going through it and making sure. So just go through it slow, you know. Slow and correct is better than fast and wrong in math. Where do we get the size of the rough opening? This is back to framing.
Schedules
What?
on the schedules.
Yeah, the schedule should have it, or you know, maybe the lumberyard will give you a catalog from that, you know, from where you're ordering the stuff, and it'll have it in it. But it should be provided. The reason you can ask that question is because when I was your age, framing, we made up our own rough openings. You know, the window was a 3-4 window, 3 foot high and 4 foot wide, and we just add 2 inches to both width and height, and that almost always fit every window. Now, if you get a 3x4 window, it could be under 3x4, in which case your rough opening, if you did it, you just added 2, would be way too wide, and you'd have to stick in fillers, which is a pain in the ass. Or the window could actually be bigger than 3x4. It's called a nominal 3x4 window, but it will be 3 foot 1 inch by 4 foot 1 inch. That happens. And so then your frame's too small. So you really need the company to spell it out, and then there's no mistake. So yeah, just for this answer, put from the door and window schedule. Then I've got a problem for a roof. I'm asking you how many pieces of plywood. I'm giving you the dimensions of the roof. And so you're going to multiply it out and get an area for the roof, and then you're going to divide by 32 square feet, a 4x8 sheet of plywood. And I say, don't worry about possible waste. In sheathing on roofs, there's 2 problems. One is the length could be such that you waste, there's some waste, but also you can't span less than 2 rafters. You can't just have a piece of plywood between 2 rafters because there's not enough nailing on that. You're only on half of the rafter because the sheathing before and after that's got the other half. And for one little piece, if you walk
Would you
on
mind
that,
to draw that out?
Yes,
The
yes,
interpreter, it's a little
yes.
confusing. Do you mind?
absolutely.
Thank you.
This is important to know anyway. So these are roof rafters. This is the ridge. They're coming down this way. Looking plan view. So the plywood, you're going to sheathe it, has to go at least 2 bays. Remember we use the word bays? So the space between rafters. You can't put a piece of sheathing on just 1 bay, 16 or 24 inches. Because when it's nailed over 2, it's got really solid nailing in that middle piece. And if it's going over 3, like most of the time, you'll have 2 solid pieces in the middle. And hurricanes and earthquakes are looking for weak points. And they'll see this and they'll pull out a piece like anything. And also if you walk on that, you're gonna flex that. You can imagine you're gonna flex that in. This one, it'll flex on this side, but this has got good, foundation for walking and putting heavy Spanish tile or whatever. So they don't allow you to do that. So the size of your roof may not work out perfectly for if you're getting to the edge of the roof, and your last piece is going to cover 3 bays. You've only got 1 bay left. You can't do that. You're going to have to cut this one before shorter and waste that piece and then put a whole piece in here. So that creates waste if the size of your roof happens to be, off of that 8-foot module. But so that's what can happen. So when I do a roof, if it's relatively small, like a residential house, I will actually draw the roof to scale, and I'll draw the plywood, and then I'll see, oh, that last piece of plywood is not going to make it. It's going to waste the whole sheet. I can't use the other part. So then I'll know how much more to order. There's a percentage that probably is close to that, but if it's a small roof, it's not a big deal to draw it to scale, and you don't even have to draw it to scale. You just have to draw it and then know that it's 2 feet between studs and just draw your plywood over it. So it really helps. But for this math problem, I'm asking you to forget about the minimum span and forget about waste. I just want you to divide the area of the roof by 32 square feet. How simple could it be, huh? Oh yeah. When laying out laying out the plates for a wall, the bottom plates and top plates, what are the marks and their letters for the stud, king stud, trimmer, and cripple stud? So I'm going to tell you what those are. A lot of you will know them. What you may not know is king stud. I think some people don't put it, but when I learned, and I think this is a better way because there's no confusion. I put an X for a stud. That's standard. I put on your layout, right? You got your wall. Put a line here and I put an X. The stud's gonna cover that X. If it's the outside stud of a window, the window's gonna be here and there's gonna be a trimmer here, usually. This I'll put a K for king stud. And then I know I'm at a window. That's a full length stud. It could be an X, but when you see the K, it tells you where you are on the layout. So it's kind of handy. So I was always taught to use X, K, and then for the trimmer, I use a capital T. So that I know is not going to be a full-size stud. If it's a doorway, it's going to be only up to the header. And if it's a window, it's going to be between the sill and the header. So it's important to mark that. What else do I say? Stud, king stud, trimmer, and cripple stud. So above an opening, here's a window. Here's the trimmer on the other side, or a door. Then your layout, your standard layout may come right here. And so instead of an X, I'm going to write a C because it's not a full-length stud. It's a curtailed stud. So say you're looking at the layout and you want to know how many studs to grab. Well, you're going to grab a stud for each X, and you're going to grab a stud for each K, and you may be able to use a shorter piece for a trimmer. In a window, it could be half a stud, and the curtailed studs are going to be usually scraps that you have lying around, or you get 4 of them out of a regular stud. So the letters on the layout help you get the material because they're going to be various sizes. But those are the standard. John, you guys who frame, do you guys use that same?
in Northern California, we always use jacks instead of trimmer.
Oh, well, yeah, that's Northern California. What do they know, you know? Jack. Use a jack for a trimmer?
Yeah, and we use trimmers in horizontal openings. So
For the sill?
no, for in a floor
Oh, on a
seal
floor,
system,
okay. Oh, yeah,
we
okay,
use a double area. We call that a trimmer.
okay, interesting.
You know,
Okay.
the jack's always next to the king. It's easy.
That is good. Wouldn't you think about that? When you were a kid?
I don't know.
That's pretty good. I like that. Jack next to the king. So if you're in Northern California, and I pity you if you have to go up there, but that T may be a J. But for this test, oh, I don't care. You can put both. You can put either. Okay. I mean, who am I to judge? But X will be standard. Use C for cripple, right, John?
Yeah.
And K for, so the only difference is sometimes they call a trimmer a jack. So jack's always a shortened piece. A jack rafter is a shorter rafter. It's cut off. A trimmer is cut off. So, you know, it follows the meaning of jack in building. But when I learned in Southern Cal, and we called it trimmers, but those things change and there are regional differences. So anything close to that would be good. And last question, don't cry. Window and door schedule should list the rough openings for each door and window. Yeah, okay, true, that's true. Even though they don't always do it, it might be a supplementary schedule from a manufacturer. But the best plans have that stuff spelled out and they'll have rough openings. You can just, when you're framing, just, you know, the night before when you frame, you might do a sketch of all the walls you're going to build and you're just going to put the rough openings. You're going to just pencil it in right there. So when you go to frame it, you know exactly what you have to cut. Any question? That should be pretty easy, huh? Since we went over the whole thing.
Got this.
So some of you are not here tonight, and I'll post the video. So if any of your friends ask you, you know, geez, I had to work. What can I do? Tell them to check out the video in their Canvas announcement section, and it'll have everything we went over. So are you guys comfortable with taking the exam from what we know?
Yes.
Yes.
Okay, let me take roll real quick and then we'll go home, yeah? Miguel. Jesus.
Here.
Alec.
Here.
I know you're here, but I'm going to call your names anyway. Hamar, are you here? Okay. Marcos, you're here. I saw you. Colby's here. Hugo's here. Eric, you're here, right? Garcia? Yes? I thought I saw you. Maybe I didn't. Dylan's here. Kevin's here. Duke's here. Brandon's here. D'Angelo, did you make it? Okay. Cesar's here. Michael Silva, you're here, right?
Yeah.
Yeah. Thought I saw you. Jose Silva?
Yeah, right here.
Yeah, there you are. John Tapia, I think I saw your name. Johnny Vasquez. Yeah. Is that Johnny? Was that John? Was that Johnny? And then Jacob Ryder Wordall's here.
I'm here.
Yeah, I know, Ryder, you're here, but somebody got a kidnapping Johnny Vasquez, and he's trying to speak through the towel over his head. No? Okay. Let's see. No, okay. if there are no more questions, this test should be a piece of cake. And I'll probably open up, I'll probably be here at 5:30 next week. I mean, on the ready for business. So if you get out of work earlier, you need more time. How was the last test? So it'll probably be similar to that in length and complexity. How did everybody need the full time for that? Like 6 to 9? Anybody stay past 9 for that test? Remember?
No, not past 9.
Yeah. Okay. Well, I'll rather than get here, John, is 5:30 okay with you?
Yeah, yeah.
Okay. So I'll start at 5:30 and I'll just make it till 10.
Sweet.
You know, like if people come late or they're just foggy that night, that should be plenty of time if I go till 10. Yeah.
Deal.
Okay. Okay. All right. And remember, I'm going to give you instructions for the test. No, I'm not. You can go straight to Canvas and take it. Yeah. Let me just say this about the test. Just like the midterm, you just go right to Canvas and do quizzes and take the test like we did. But I'm going to be on this Zoom doing research or whatever I do at night. And so if you have a question, if you get confused about a problem and you need to talk to me, just come on the Zoom, okay? And I'll be here to answer your questions. And if I'm not, like if I have to go, you know, to the bathroom or go and get something to eat for a few minutes, just keep trying because I'll be here. So if for some weird reason I'm away from the screen, just wait or you know, phone call or something. Does that make sense? So and if you don't have any problem with it, you can just take the test on Canvas and, you know, submit it, and you don't even have to come to the Zoom. Okie doke.
Yeah.
How do you say okie doke in sign language?
We just so you know, we can't answer while we're signing. So that's why every time you ask, we're silent. So just so you know that.
Well, so how do you say okay? So if I asked you to say okay, you could sign okay, right?
So yes, Katie is signing.
Yes, we
okay.
can.
Okay.
So,
Okay. Yeah, I mean, those are the obvious ones, right? Okay. And I just was joking with okie dokie. Not everybody even uses that phrase, right?
I use it every day.
Oh, who said that? Yeah. No, I'm just giving you guys a hard time. I'm trying to pick up words that are regional or weird. But a lot of people use okie dokie. There'd be no problem with just saying okay for okie dokie, right? Yeah. Yeah, that's probably how you translate anyway.
Yeah.
Because you'd have to have a symbol for okie. No, we don't want to go there. Okay. So thank you, everybody, especially you signers and you captioner Debbie. And so you guys, so captioner and you won't come to the regular Zoom, but you'll be in contact with Hugo, right? In the way you do it.
Yes.
Is that right?
Yes.
Okay. Okay, super. All right. So I'll be here and you guys can take the test and then we'll see how you did the next week. Okay.
Peace, yeah.
All right, everybody. Have a good night.
You too.
All right.
You.
See you later.